my back.
Yeah, I'm just hoping I ain't gotta officially come back.
I'm just sitting in the cafeteria of my job, just waiting.
I don't know
Oh,
who
how's
said
everyone's Thursday? What?
I don't know who said it earlier, but it was a good idea. They was like, "Why can't we just take the test like on WebAssign?"
I think Benjamin said it.
Yeah, because I feel like this would be do too much.
Yeah, she want to watch us take it.
Why?
All right, I'm back. Sorry about that.
Yes, Mr. Harris. Dr. Harris. All right.
This is not easy. Okay? Having a free stuff is not that easy.
All right.
All right, so I'm recording again.
Oh, so did you record the last meetings?
Yeah, the first 30 minutes. Yeah, I did.
Okay, because I didn't remember. I don't remember you posting it. The second one, at least.
I think
Yeah,
9.2 and 9.3.
I'm gonna have 2 recordings per day. Yesterday, I forgot to record the first half, so I will need upload the second half. But I am recording right now, so you should have both of them today.
When you say recording, is that just your screen, or is that the audio of us as well?
Yeah, it's everything what we do, screen and audio. So you talking, it's also recorded. I'm talking is also recorded. So what we're doing here is recorded.
All right.
Okay. All right, so is everybody here? Okay, I need to admit more people. Okay. If you cannot get in, let me know, so I know. Because I had 14 people, I only have 12. That means I lost 2. Okay, so does everybody understand today's lesson? So let's look at the homework problem so we can practice a little more.
On the Bible.
Here's 9.4. Okay, let's look at the 9.4. Okay, is everybody with me now? Can you see my screen okay? All right, so let's look at 9.4. Look at number 1.
Is that a drop-down menu with a question mark?
Which one?
Oh, never mind. I see what it's for. Okay, it's for greater than and less than all that. Okay.
Okay. So do you see the first one? Okay, so does everybody see why this diverges? Okay,
No, I don't get why it converges. I actually don't.
I don't fully understand convergence and divergence, to be honest with you.
Okay, so looking at this would be similar to which one?
It's a P series, right?
Yeah, 1/3/4. They're similar, don't you think? This and this is very similar. Yes or no?
I would say no, because it's a whole -1.
I mean,
Okay,
I
so
can see why.
-1, and this one does not have -1. So you need to figure out which series. I'll call this is the A, this to be B series.
Okay, so A is bigger than B. No, wait, B is bigger than A. Sorry.
So, okay, let's just look at this easy number. Start with 1. N equal to 1. Then A sub 1 is equal to 1/1. Let's show the 2 because 1 does not. Because 1 give you what? 0. So let's try the 2. So you get 2 to the 3/4 minus 1. The other one would be what? 1/2 to the 3/4. So which one is bigger? A sub n, or B sub n?
B sub n.
B sub n.
Okay, you can think of Okay, this denominator is less than 2 to the 3/4. Are you with me? So just think of, if I give you 1/3 and 1/4, which one is bigger? This is equal to 0.333. Which one? This one equal to 0.25. So which series is bigger? That's
0.33.
bigger. So this, excuse me, this is bigger, right? Because 0.33 is bigger than what? 0.25. So smaller
Right.
denominator, are you listening? Smaller
Yeah,
denominator give you what? A bigger series. So this is what? Larger series. This is what? A smaller one. So are you with me now?
I believe so.
Not yet. Okay, hold on. Let me see. Let me explain in a different way. First thing first, the comparison test. What does the comparison test say? So I'll call it AN is less than or equal to BN. They're bigger than 0. Okay. So what does the comparison test says? It says if AN is what? If AN diverges, then what can you say about the BN?
It also diverges?
Right. So smaller one, so another one you can just say smaller series diverges, then what can you say of the bigger series? Bigger series also what? Diverges. So we're comparing 3/4. So this is my AN. This is my BN. So since this one diverges, what can you say about this?
It also diverges.
They also diverges. All right. So, but now I need to ask you why this one diverges. By what do I know?
The
Makaya,
P series.
Yeah, P series. The P series says that if the P is what? Less than 1, then what happens? Diverges. So 3/4 is less than 1, isn't it? Because 3/4 is 0.75.
Okay, I get it now.
Okay, are you with me now? Colin, are you following me?
Yes, ma'am. That explanation right there just really helped.
So
Okay,
really,
so
it's like is it the like exponent, the fraction that is an exponent if it is less than 1?
right, the P, the exponents. That's right. The P is your exponent. If that is less than 1, right, then diverges. The P has to be greater than 1 to be a what? Converges.
Okay, so really, when we get one that's like it is with the fraction, we can just, like you say, P is our exponent. So we can just look at that one off top and just determine if it's greater than or less than 1, determine if it's converges or diverges.
Right, exactly.
Okay.
So let's look at a similar problem. Let me see, there's another one like that. Okay, I don't give you another example. All right, so now let's look at the second one. Okay, second one, you gotta think about it. What does it look like? You gotta think about the series that you know, that definitely you know that converges or diverges. So this case, for me, I would think about this series, 5/6 to the n. Because I know what to do about the 5/6 to the n. What kind of series is this? Anybody know?
Geometric.
That's right, that's a geometric series. So geometric series, it says what? So R is equal to 5. R is equal to 5 over 6, which is what? Less than 1. In geometric series, if the R is less, it has to be actually absolute value, okay? The R is less than equal to 1, then it's what? Converges. All right, so now we got the direct comparison. So when you do direct comparison, you got to figure out which one is a smaller series and which is a bigger series, right? So I got to think about it, 5 over 6 and 5 and this one. So let's plug in some number and see which one is bigger. So let's try with the n equal to 1. Then I have 5 over 1 over 6 over 1 plus 3, which gives me 5 over 9. What's the other one? 5 over 6 to the 1, which is 5 over 6. So which one is bigger? This or this? Which series is bigger? 5 over 9 or 5 over 6? 9 is a bigger denominator, so this will be what? Smaller number, isn't it? Are you following me?
Yeah, I
Yes,
was just
ma'am.
talking without a mic. Okay.
Yeah, so 5 over 9 is a smaller series. So I can put this to be what? And my bigger one would be what? All right, so now I know this converges. My bigger one, the bigger one converges. What can you say about the smaller one?
It converges.
That's right. So I just did a direct comparison test. So in other words, you cannot do the comparison test unless you already know some series that already diverges or converges. So divergent one, very similar one is like 1 over n, that you know it's for sure diverges. And then what do you have? Give me another one that diverges. Like 1 over what? 3 over 4. P series, there's something less than 1, right?
Yeah.
Tell me
Yes,
the
ma'am.
convergent series. Any geometric series is what? The R is less than equal to 1 converges. For example, like 1/2 to the n, the geometric series with converges. I can make up another one. So 3 over 4 to the n, any of a geometric series that R is less than 1, it converges. So you need to know some of them already in your hand, so you know how to compare things. And another thing we use a lot is what? P-test, P-series, like 1 over what? N squared converges. Like 1 over n to the like 3 converges. Are you with me? So you need to kind of know this. Otherwise, you don't know how to compare. You don't know what to compare with. Because did you notice this? They didn't give you the 5 over 6. You have to figure that out.
Is it not just taking the equation given and just see, in my mind, we take out the constant, which is 3, and then because both 5 and 6 are raised to the n power, we just put 5 over 6 and put.
That's why, because this will give you a hint to write down like this. Exactly right. Exactly
Okay.
right.
Can we do a limit one?
Yeah, let's do
Please.
limit.
Is there a limit one on the homework?
Yeah, sure. Right here. Number 5. Use the limit comparison test to determine the convergence or divergence of the series. All right, so I have this. Okay, so again, I'm gonna look at this. Since they have the same power. So I'm going to say, okay, I will probably want to compare with Are you with me? You see, tell me, why am I doing that?
I see, because the first, like, the numerator is 4 to the n, the denominator is 5 to the n. So basically, you're taking both, and it becomes 4 over 5
Right,
to the n.
because looking at this, I'm gonna do something that I know, because this is n 4 to the n power, this is 5 to the n power, so I can just put 4 over 5 to the n power, which means it's a geometric series. R is 4 over 5, which is less than 1. So I know this series will be what? Converges. Right? So I'm gonna do limit test. So I'm gonna put 4 over 5 here. All right, but I already know, since the bottom one, that converges, what can I say about this one? What can you say about my problem?
Does it converge as well?
It converges,
okay.
Right? Yeah, so, but, you know, if you want to do the test exactly like, I mean, this one, actually, I don't even have to do limit comparison test, but let's do the limit comparison test. Since the problem says do the limit comparison test. That means I will take a limit, n goes to infinity over 4n plus 1 over 5n plus 1. Everything over, I'm going to do 4n over 5n. So this goes to denominator. This outer one goes to numerator. So I have a limit, n goes to infinity. Then I have 4n plus 1, everything multiplied by 5n. Everything over 5n plus 1 over 4n. Okay, are you with me?
Oh, yeah, I see it. Okay.
Are you following me? Because I am just simply doing, this is my problem. This is a given problem. And that's the one I use because I want to compare with this one. That's something that I already know.
Okay.
Right. Multiply by the reciprocal.
So multiplying the inner one goes to denominator. The outer one goes to where? I mean, inner one goes to denominator, outer one goes to where? Numerator.
Okay, so the one that you're doing down here in the bottom right that you just did, this is the actual test, right? Like the comparison?
Right.
Okay.
Right. So the one I did it right away, I knew this is converges. I know this has to be converges, but they specifically ask you to do what? The limit test. So I am doing a limit test right now. So this is the algebra that I'm doing. This is how you do your algebra to do the limit test. So if I just simplify a little more, then I get a 4n times 5n plus 5n, everything over what? 4n times 5n plus 4n. Right? So looking at this, if I decide to multiply everything by, like what I've been doing, like say if I decide to multiply everything by 4n's, but they're practically it's equal to 1. All right, so for example, so biggest one is what? Right there, they're exactly same. So they're converged to where? 1, which is a positive number. The limit test says if you have, when you take a limit, they give you positive number instead of infinity, any positive number, then you can do direct comparison limit test, which means if one of them converges and the other one is also what? Converges. So since we know this converges, we can say about that also converges. That's what they're talking about here. Does it make sense to you guys? Yes?
Kind of. Yes, yes, ma'am, it does.
Okay. Anybody else have questions? So if you want me to, I can do one more problem. We already spent on about 53 minutes already. So if you want to do your problems by yourself and ask me tomorrow is fine. Or if you want to do another problem now, I can do another problem. You guys want to do problems by yourself and ask me tomorrow? That sounds
I'll
good?
ask you tomorrow.
Okay. All right.
Yeah,
so
that's
we're
what I'm gonna do.
for today's class. So do your homework today. Okay, 9.4. So you can ask me tomorrow. And then we'll do
so much homework.
So we'll do some homework problem. You guys do your homework problem, then ask me tomorrow. And then we can do 9.5 after that. And also, hey, Colin, did you do the attendance for me?
Yes, ma'am. I took attendance. I pretty much got everybody. I checked it when we first started. Then I also just checked it again, and I see a few more came.
Okay,
so
because I have a notebook 9. I don't know who that is.
Yeah. I don't
know. That's me. That's Laterica.
Oh, okay.
Oh, that's okay. Laterica. Okay.
Oh, so it popped her up as twice, so yeah.
Because I need to know your names. Like I see Patrick, and I see May, I see Makaya, Jordan, Ajaya, Colin. I see that.
Mm-hmm.
So put their name.
I think Lauren lagged out. No, wait, never mind. She's still here.
Yeah, I got Lauren now. I got Makaya, Miss Laterica. I got Quincy. I got Lauren. I got myself. I got Alfonso. I got Jordan Dilworth. I got Ben Overton. I have Isaiah Jordan. I have Mayona Dunn. I have Patrick. And I also have Quincy.
Okay. That looks like good. So just send me a text message or something. Because I do have a screenshot in case I don't have everybody. I just want to double check. Okay. All right, you guys. Have a good day, okay? Have a
wonderful day
tomorrow.
Have a good day, everybody. Wash your hands.
Yes,
that's
please.
Right, definitely.
You all too.
All right. See you tomorrow.
See you.
All right.